Hello dear students, welcome back to the tetrahedron chemistry classes. So dear students, in today's class I am going to discuss a little different topic other than chemistry, and this topic is related to the environmental studies, right? And the name of the topic is the nuclear hazard, right? So this is a very important topic for every student of any stream, like be it your BA or your BSc or your BTech or your pharma, because in first year environment science is compulsory, and this nuclear hazard, this topic is particularly important right there, and especially for the UPSC aspirants this topic is again very important. However, that much of detail up to the level of the UPSC I didn't included in this particular slide, but to get the basic idea this lecture would be very helpful for you. Okay, so without wasting too much of time, I'm going to start this particular topic, right? And you can see here the three pictures are there, and the picture you can see which is on the extreme left, right? This picture is of child standing after kicking another child on his back, right? This picture went viral on the social media a year and a half ago. Okay, and people made this picture viral with different stories, but its real story is something different, right? This picture is of the time when nuclear attack was carried out by United States of America, right, on the Hiroshima and Nagasaki cities of the Japan, right? So this was the picture of that time. This is something very important you should know. Okay, and if you go through the history of this particular picture, then this picture was taken this picture was clicked by the American photographer Joy O'Donnell, and Joy O'Donnell itself wrote about this picture, right? And you can read what he wrote about this picture. I'm just telling you that in his words actually, right? What Joy O'Donnell said about this picture, right? He said, "I saw a boy about 10 years old walking by. He was carrying a baby on his back," right? In those days in the Japan, we often saw the children playing with their little brothers or the sisters on their backs. Okay, but this boy was clearly different. I could see that he had come to this place for a serious reason. He was wearing no shoes, as you can see. There are no shoes on the feet of the child, right? His face, you can see, his face was very hard and still, and the little head was tipping down, tipped back, right, as if the baby were fast sleeping, right, on his back. The boy stood there for 5 to 10 minutes, and after that, men in the white mask from the graveyard itself walked over to him and quietly began to take off the rope that was holding this particular baby, right? This is when I saw that the baby was already dead, said by the Joy O'Donnell. The men held the body by the hands and feet and placed it on the fire for the cremation. The boy stood there straight without moving and watching the flames. He was biting his lower lips. This boy was biting his lower lips so hard that it shone with blood. The flame burned low like the sun going down. The boy turned around and walked silently away. And when I read these statements by, or say this, really I felt very sad about the people who were the victim in the Hiroshima and Nagasaki attack. These were the fruits of the war, and these fruits are very ugly, very dirty, not so sweet, right? So this picture is very important. And similarly, on the right hand side, extreme right, you can see another picture taken from the same place, right, Hiroshima and Nagasaki, and where I have shown you the victims who exposed themselves to the exposure given by the nuclear attack, right? So here you can see the limb of this man is not in proper shape and it is injured as well. Similarly, you can see this limb, right, and then this girl having bandage on the right of her forehead. Similarly, you can see the finger of this lady. Again, this is the after effects of the attack, right? So these nuclear hazards are very dangerous. And in the center, this is the logo of the nuclear hazard, say in some container, okay, in some container, or say in some packet, in some medicine. If you find this logo, you must be understand that okay, that particular container is having certain thing which is radioactive in nature, right? So this is just the introduction of these three pictures. Now you can see what are the nuclear hazards, what they are actually. So basically these nuclear hazards are nothing but they are the radioactive substances, like, right, like uranium, plutonium, and many more you have already seen, okay. And what are the these nuclear substances? Nuclear substances are the substances which undergoes spontaneous decay, okay. And due to this spontaneous decay, they form very fast moving particles, and these particles have very high energy or very high radiations. This is important, very very important. And all these these radioactive decay generally give you the three kinds of the particles, like alpha, beta, and gamma, right? So alpha particles are positively charged, very fast moving. Beta particles are negatively charged, again very very fast moving. And gamma are very very high energy radiations. Penetration power of the gamma is very very high, and it is fatal for any individual, be it plant, animal, or human being, okay. So uranium, plutonium, and many other radioactive substances, when they undergo the disintegration, they actually remove, or this not remove, they actually emit these kinds of the radiations, okay. Then you can see the penetration power. So this is alpha, and that alpha is positively charged, and the penetration power of this alpha is not very very high, but this alpha is very very dangerous, very very dangerous. Please remember this point. And it cannot penetrate a simple paper, or you can say the skin of the human being. So whatever the attack it will do, it will attack only on the it will affect only the skin part. But when you ingested any kind of the material which is radioactive in nature, then inside the body, if alpha particles are there, they can damage your organ as well. Then there comes the beta negatively charged particles, very high speed moving, but their penetration power is comparatively very very high to the when compared to the alpha particles, right? But again you can see it can penetrate through your skin or the paper, you can say, but it cannot penetrate the 3 to 5 millimeter aluminum sheet, okay. And then there comes the gamma and the X-rays, right? These X-rays are also carcinogenic in nature. It can it causes cancer, okay. So gamma rays, again you can see it can penetrate this 3 to 5 mm of the aluminium, and it can go through the lead. It is not this gamma radiation cannot penetrate your lead, but it can penetrate 3 to 5 mm of the aluminium. So their penetration power is very very high, okay. And you can see the some of the very hazardous, or you can say the dangerous effects of the alpha particles, right? So as I have summarized here, alpha particles are highly ionizing in nature because of their double positive charge. Large mass compared to the beta particle. See, it's very high compared to the beta particle, right? Large mass, see, double positive charge, large mass, and because they are relatively slow, okay. When compared to the beta, they can cause the multiple ionization within a very small distance. This gives them the potential to do much more biological damage for the same amount of the deposited energy. That means whatever the, say if you have a particular amount of the energy deposited somewhere, and you have the equivalent amount of these alpha particles, then it can cause severe damage to the biological system. That's why I said due to due to double positive charge, it is very highly ionizing, and it is having very large mass and very relatively low speeds, right? So this makes it more dangerous compared to the same amount of the deposited energy, right? And again you can see alpha particles cannot penetrate the normal layer of the dead cells, right? If alpha particles are bombarding on your skin, it can not penetrate the dead cells, right, on the outside of the skin, but can damage the cornea of the eye, right? It cannot damage your skin, but it can damage the cornea of the eye, so the person can suffer with the blindness when the alpha particles attacks on the cornea. This is something very very important we should know. Alpha particle radiations is normally only a safety concern if the radioactive decay occurs from an atom that is already inside the body or a cell. Okay, so when you ingested, say, certain material which can spontaneously gives the alpha particles or emits the alpha particles, then it will be more dangerous, right? So alpha particle emitters are particularly dangerous if inhaled, ingested, or if they enter a wound, right? Say if you are suffering from any injury and you have developed wound, then these alpha particles would be very, very dangerous. You should remember this particular point. And see, few years back, say 10 years back, I have seen a crime report on Discovery Channel, where, see, there was a case study, right, of murder case in America many years ago, right, in which the culprit had mixed the radioactive substances in the cold drink bottle to kill the entire family. So it can kill the entire family as well, right, if you mixed in the food articles or the drink articles. And then there comes the beta particles. Why these beta particles are hazardous in nature? Beta particles can be stopped by a layer of the clothing. See, whatever the clothes we generally put on, right, or say that thickness of the cloth, right, it's able to protect our body with the attack of the beta particles. And beta particles are capable of penetrating the skin and causing radiation damage such as skin burns. See, we generally don't put anything on our face basically, right? If beta particles are attacking on our face, then it can penetrate our skin and then can cause the radiation damage like skin burn, scars, right? All these things, right? As with the alpha emitters, beta emitters are most dangerous, right? These beta emitters are most dangerous when they are inhaled or swallowed or absorbed in the bloodstream through the wounds. See, as I have already explained you, when you ingested a radioactive material which can emit the alpha particle, it can cause severe damage. But simultaneously, see, if it is emitting alpha particle, it is always possible that it can emit beta particle as well, and when it emits the beta particle, then it would be more dangerous than the alpha particles. So these alpha and beta particles are very, very dangerous. Please remember this point. Okay, so gamma rays and the x-rays, they are highly penetrating, right? Several feet of the concrete or a few inches of the lead are required to stop them. If you want to stop the x-rays or the gamma rays, then you need the several feet of the concrete, right, RCC, or a few inches of the lead, because they cannot penetrate the lead. Okay, gamma rays and x-rays are radiation hazard for the entire body, right? While gamma rays and x-rays can easily pass completely through the human body, some fraction of the energy will always be absorbed by the body tissues, and then body tissues you could be damaged or would be damaged, right? So again, you can see these three particles, which are the result of the spontaneous decay of the radioactive materials, are very, very dangerous for the human beings, right? Animals as well as for the plants. Which radiation is the most harmful? Okay, it depends on whether your exposure to radiation is internal or external, right? See, if it is internal, then every kind of the radiation is very, very dangerous for you, and if it is external only, then definitely you will suffer to a minimum extent, right? Depends on the particle which are bombarding on your skin, whether you are alpha, beta, or the gamma. Generally, alpha particles are most harmful internal hazards. It is not external hazard, but it is internal hazard, as I have explained to you. But these gamma and the beta are the external hazards as well, along with the internal hazards, right? Please remember this point. Okay, and then you can see radioactive materials that emit alpha and the beta particles are most harmful when they swallowed, inhaled, absorbed, or injected. Gamma rays are the most you can see the harmful external hazard, very, very harmful. Please remember this point. Okay, sources of the radioactivity, from where actually these radioactive substances generally comes from. This is again very important aspect. Okay, so first of all, natural sources. What are some natural sources which actually emits which gives the radioactive substances? First of all, the cosmic rays from the space. See, generally everything is present in the space, right? And when everything is present in the space, definitely it will also present in the earth as well, right? As you know, because our earth itself is formed by the supernova activity. I hope you know what are the supernova activities. Okay, right now I am not explaining you what are the supernova activities. It is the activities which occurs in the space or in the stars actually, right? So this earth itself is formed by the supernova activity, that is the star breaking down on and all these things, right? So whatever material remains in the stars, in the space above, right, it also remains on the earth as well. This is the source of the radioactive substances on the earth. Okay, and then when it is present on the earth, definitely it will be present on the soil as well as present on the rocks as well, right? And when it is sometimes it may also happens that not actually the radioactive substances, but the radiations like alpha beta particle which emits from these radioactive substances, they may present on the air as well. Once the radioactive substances are present in the air, soil and the rocks, definitely through the leaching or through during the rainfall, right, then it can come into the water bodies as well. And when the radioactive material is there in the water body, is there in the soil and the rocks, it can come into your food as well through irrigation and many parts, because any kind of the food which is available for us, we generally are extracting or harvesting from the earth, right? So when earth pool is having the these nuclear active substances, right, definitely it would be there in your food as well. Okay, and then after the natural sources, anthropogenic sources are also there. Some anthropogenic sources. Anthropogenic sources is the technical term for the man-made sources. So if I can write here, anthropogenic means man-made. Please remember, anthropogenic means man-made. So man-made sources, you can see, first is the nuclear power plant, right? First is the nuclear power plant. Siting the nuclear power plants anywhere can cause the damage to the nearby vegetation, can cause damage to the animals and the human beings as well, right? And second, there may occur some nuclear accidents, right? So there are various nuclear accidents and nuclear war as well. Hiroshima and Nagasaki, I already explained to you. Okay, and you can see the Chernobyl nuclear disaster is also there, right? So nuclear accidents are also anthropogenic, man-made, right? And then the X-rays are again very hazardous in nature, right? And again it comes from the anthropogenic sources, sometimes for the beneficial purposes and sometimes accidentally, right? So you know, this X-rays has a very large number of the you can say the positive effects, right? From the time of its discovery, X-rays have saved the countless life on the earth, right? So their positive effects or their healing effect far outweigh than any negative outcome, right? And then for the treatment of the certain diseases, we use the certain pharmaceutical kits or the diagnostic kits, and those kits itself generally have the radioactive substances there. In a few minutes we'll see or we'll go through through these kits as well, which can give a person nuclear hazard, right? And then there occurs the nuclear test, and nuclear test, you know, whether it is your CT scan. CT scan is your computed tomography scan, right? And then MRIs, magnetic resonance imaging. Earlier it is known as the NMRI, nuclear magnetic resonance imaging. But in the European countries and in USA especially, people are very afraid of this term nuclear. Then scientists decided to remove the term M from the MRI. Now it is on N from the NMRI. Now it is only MRI, magnetic resonance imaging, and your CT scans, your X-rays and various things. And these laboratory tests can also expose a person to a very high radiation, right? These are the man-made sources. Please note that. Now see, since natural, as I can go back, these natural sources I have already explained here, but man-made sources are very, very important. So I'll discuss all of these: nuclear power plants, nuclear accidents, X-rays, diagnostic kits, and the test laboratories, which can give any person to the exposure of high radiations, right? So nuclear power plants. So nuclear power plants generally uses the radioactive material like uranium 235. And for your knowledge, you should know that the natural uranium 235 is having only 0.7% fissionable material. That means it would be not a very good idea to put the natural uranium 235 in the nuclear power plant as a fuel. So what generally scientists do, right? What generally the chemists do? They actually artificially enrich this natural uranium or radioactive material, and after the artificial enhancement or the concentration, then artificially enriched uranium will have the nearly 3% of the fissionable material. That means it can produce more energy, which can be used for the beneficial purposes, that energy, right? But see, this energy not only for the positive, this energy cannot always be used as the positive aspects, right? Sometimes it may also involve in the nuclear attack or like these things, right? So this is another aspect. However, those days have gone now. The war days have gone now. Now the current war is what? Economical war, right? Economical war. So if you want to destroy any country, right, destroy it economically, right? Those nuclear attack and all these things, though various countries are having the nuclear power, but they cannot use these nuclear power. Okay, now moving further, approximately 17% of the electrical energy generated in the world comes from the nuclear power plants. Currently, whatever the amount of the energy which we are producing in the earth, 17% of it is coming from the 17% of it is coming from the nuclear power plants, right? And world's first electricity generated was constructed by the USA in 1951. Please remember, okay? So first controlled fission of an atom was carried out in Germany in 1938. However, the fission was carried out in 1938, right? But the machine was constructed by the USA in 1951 to produce the electricity. Okay. So in nuclear, what happens generally in the nuclear power plants? In nuclear power plants, as the nuclear fission occurs, due to this fission, the heavier isotope will convert into the lower isotopes, and due to this disintegration, it will emit the alpha, beta and the gamma radiation. So what will happen when you use these radioactive material, especially uranium 235 in the nuclear reactor? What will happen during the use of this uranium 35, after about 3 years actually, what will happen? The concentration of the fissionable material will decrease drastically. Okay, the fuel rod does not have the enough radioactive material then to sustain the chain reaction, and when chain reaction is not there, then it is not of much use. Then these rods must be replaced by the fresh rods. But the problem is that these used rod still have certain amount of the radioactive substances, which is very, very dangerous for the human beings, animals, as well as for the property or the say vegetation as well. Okay. So here you can see, however, these spent rods I have already explained to you are still very radioactive, containing 1% uranium 235 and 1% of the plutonium 239. These rods are the major source of the radioactive waste, and the disposal of this waste is very, very important, right? So and so far we don't have a very foolproof or the very safe idea to dispose them. Whatever the methods are available, we are doing with those methods, but they are not very, very safe, right? And here you can see, if you want to measure the radiation exposure, so to measure the radiation exposure, the unit used is the Ronton unit. This Ronton unit is after the name of the scientist, right? Ronton. In a few slides, see, after a few slides, now then I am discussing the nuclear accidents. I explained the nuclear power plants, what is the source of the radioactivity in the nuclear power plants. Now I am discussing the nuclear accidents, and the accident which I am going to discuss here is the Chernobyl nuclear disaster. And this picture I have taken from the iStock. Credit goes to the iStock library for this particular picture, right? So 26th April 1986, this nuclear disaster was taken place, right? Or took place rather, right? Chernobyl is a very small city in the Ukraine, Russia, near the border of the Belarus, north of Kiev. Okay, this is the location of this Chernobyl city. So in the Chernobyl nuclear plant, power plant, right, on the 25th April of the 1986, at the night 1 a.m., a test to measure the amount of electricity that the still spinning turbine would produce if steam was shut off being conducted at Chernobyl nuclear power station 4. And this was a very foolish experiment done by the technicians there. What they were doing at the power station 4, they were checking that if we stop the supply of the steam, then again you can see the turbine is spinning, and after the shutting down of this steam, whether it can produce electricity or not. So what will happen when they shut down the steam flow? Then steam was accumulated on a chamber, and due to this high pressure, that chamber was blasted. Right, the chamber was blasted at that time. This was a very foolish experiment done by the technicians there. So here you can see the Chernobyl accident in 1986 was the result of the flawed reactor design. It was not the, see, I'm not agree, or I cannot agree with this statement that the Chernobyl accident was the result of the flawed reactor design, right? Because these was the industrial reactors, cannot be flawed at all, right? But it was the mistake of the technicians there. Okay, and so however it is written there, was the result of the flawed reactor design that was operated by inadequately trained personnel. This was fine, inadequately trained personnels, right? This could be happened, right? The resulting steam explosion, as I have explained to you, due to this resulting steam explosion and the fire released at least 5% of the radioactive reactor core into the environment. That means whatever the radioactive material was there in the nuclear power plant, out of this 5% actually due to the explosion or the fire was released in the Europe, many parts of the Europes. Okay. This was the problem actually. So the two Chernobyl plants workers were died due to the explosion on the night of the accident, and a further 28 people died within a few weeks as a result of the acute radiation syndrome. Okay, this was the report put forward by the management, right? This was the report put forward by the management. This is something very important you should know. Okay. And then moving to the next slide, right, you can again see the United Nations Scientific Committee on the Effects of the Radiation has concluded that apart from some 5,000 thyroid cancers resulting in the 15 fatalities only, there is no evidence of the major public health impact attributable to the radiation exposure 20 years after the experiment, right? This was actually the report given by the United Nations. And see, I have written here, this is the false story, and you should know that definitely it's a false story, and you are aware about this particular fact that, see, if any government of any country, right, be it India, America, or any other country, right, if any government has to show the goodness of their work, of its work, it exaggerates the data. And if that government has to show its failure, like this nuclear power, your Chernobyl nuclear disaster, or Bhopal gas tragedy, you can say, or any other experiment or any other accident or the mishap, then the government often show it by reducing the number of the casualties. That's why I have written this is a false story. Right, so according to me, this is a false story which says that only 5,000 thyroid cancer were there, and out of these 5,000 only 15 fatalities were there. This is absolutely rubbish. Okay, and then there were of course immediate fatalities, but the long-term consequences were devastating. This is the clear report that immediate fatalities were there. And long-term consequences were also very devastating. Approximately 1,16,000 people were evacuated from there, right? Of whom 25,000 have received the very high doses of the radiations, right? This is the correct picture actually. So in this accident took place on the 1986, and then after 10 years in 1996, right? It was clear that one of the long-term effect was the increased frequency of the thyroid cancer in the children. These radiation exposure were very fatal to the children, right? They develop the thyroid cancer due to the radiation exposure, right? And then this is the this is the picture of the COCOS Thyroid Cancer Fund, which actually treat the patients or the children which who suffered from this, who suffer from the thyroid cancer, right? So if you want, then you can donate certain amount to their, right, to them as well, right? And you can see this is the throat cutting down after operated, right? This was the treatment. So this these are the fruits of the war. Not very sweet, not sweet at all. Then you can see, okay, this is the same slide I have repeated again, and now this is again a very important thing which you should know actually, right? There are two visible, or you can say there are two visible things which are the result of the radiation hazard. Okay, monoadactyly and polyadactyly. What is this actually? You can see here. This is the picture of the monoadactyly. What generally happens in the monoadactyly, the fingers of a child, or fingers of any generally in the child's, right? So when the newborns are there, then these newborns develops this particular monoadactyly due to the radiation hazard, right? Fingers of the hand or the feet, actually they fuse together to form a paddle. So generally people have the 5 fingers in the hand or in the feet, and in case of the monoadactyly, if some person suffers from this monoadactyly, then these may fuse together to form a paddle like of thing. Then another problem is the polydactyly. What is the polydactyly? More than 5 fingers in the feet or in the hands. As you can see here, 1 2 3 4 5 6 7 fingers are there. So these were the result of the radiation exposure. See, but in India the story is something different. This generally happens a lot in India due to the superstition, you can say. If someone has the 6 fingers on his hand or in the foot, people say, oh, that he is very lucky. And the clear example is what Hrithik Roshan is. So handsome, he's a superstar, he's having that much of money. As it is having the 6 fingers in his hands, oh, he's very lucky. No, it is not very lucky. It is certain kind of the complications, right? Not necessarily due to this radiation hazard, but many other complications are also there, which can give more than 5 to 6 fingers in your hand or in the foot as well. Okay, so you can see monodactyly, fingers fuse together to form a paddle due to the genetic anomalies by the radioactive materials. Not necessarily always the radioactive materials, some other things may also be there. Then polydactyly, more than 5 units in the hands or in the feet. Please remember. And you can see this is the Dr. Pughzendi, Dr. V. Pughzendi, a teacher and a scientist who suffers a lot due to his case studies. And this generally happens when you raise voice against the developmental project of your country. Then government will actually grab you by putting some of the charges on you. This happened with the Dr. Pughzendi, and Dr. Pughzendi is very famous actually, right? He reported the same kind of the things which were there in the Chernobyl nuclear disaster in the Kalapakkam power station. This monodactyly, polydactyly, he also found that cases there. And doctor itself write that I am a doctor being victimized for telling the radiation truth, right? Dr. Pughzendi from the Kalapakkam. So a similar phenomenon has also been observed in the villages and the towns around the Kalapakkam nuclear power station south of the Chennai in an ongoing study by the Dr. V. Pughzendi. Okay. And then there comes the X-ray. On November 8, 1895, German physics professor Wilhelm Röntgen, after the name of the Wilhelm Röntgen, there is a Röntgen unit to measure the radiation exposure, right? So William Röntgen stumped on the X-rays while experimenting with the Lennard tube and the Kruger tubes. The physics people know that what are these tubes, right? I am not aware about these tubes, but you should know that with these Lennard and the Crookes tubes, he was doing certain kind of the experiment, and then he suddenly actually found this kind of the radiation, which was here X-rays. X-ray are a very now currently X-ray are very vital imaging tool used around the globe. Since first being used to image bones over 100 years ago, X-ray has saved countless lives and helped in a range of the important discoveries. This is something very, very important, which are the positive aspects of the X-rays, right? But these X-rays are carcinogenic. Please remember, carcinogenic means which can cause cancer. So if you want, then I can write carcinogenic. C-A-R-C-I-N-O-G-E-N-I-C. Carcinogenic means cancer causing. Now you can see the X-rays are naturally occurring type of the radiation. Definitely they are classed as the carcinogens, that is cancer causing. The benefits of the X-rays are far outweigh any potential outcomes, right? Computed tomography, which is CT scans, give the largest dose of the X-rays compared to the other X-ray procedures. Again, a very important thing. In X-rays, bones show up white and gases appears black, as you know already. So there is not much important thing in this particular slide, but I have summarized 4 or 5 points here, which are important in writing in the examinations. Okay. And this is the person undergoing the MRI or certain kind of the laboratory experiment, which can give a person a very high dose of the radiation. And sometimes it is very, very important. Please remember this thing. Okay. You generally avoid these kinds of the radiation exposures, right? So, see, I have seen many people unnecessarily say on yearly basis or say in half yearly basis, they go for their test. They undergo for the these CT scans, MRI as well, without any complications or the problems, right? This is not good at all. Please remember. Okay, so this is my suggestion. My suggestion is that you should never unnecessarily expose yourself to the radiations, and unnecessarily medical tests which carry the risk of the radiation exposures cannot be done at any cost. Please remember. And you can see the first person, this is something about the history of the X-rays. The first person to receive an X-ray for the medical purpose was young Eddie McCarthy of Hanover, who fell while skating on the Connecticut River in 1986 and fractured his left wrist. So a boy named Eddie McCarthy fractured his bone during the skating, received the first treatment or the first imaging with the help of the X-ray. And generally what happens, to produce a standard X-ray image, the patient or the part of the body which is actually actually the fractured, right, is placed in front of the X-ray detector and illuminated by the short X-ray pulses. It is very, very important, and generally in the MCQs type of the question, or say in the one marker, generally this question has been asked. Short rays, long rays, medium rays, X-rays, which one is used in the X-ray? So you should know X-ray, short X-ray pulses are used, right? Because bones are rich in calcium, which has very high, this calcium is having a high atomic number, which is say 20, atomic mass is the 40. The X-ray are absorbed by the calcium, and thus these bones appears white on the resulting image. This is a little technical. If you don't want to write or learn these things, forget about this. Okay. And then the risk associated with the X-rays. X-rays can cause mutation in our DNA, deoxyribonucleic acid. It's a genetic material. It can cause the mutation. Mutation nowadays is a very, very common term especially after the COVID-19 disease. See, during the COVID-19 disease, we generally heard this thing that this virus is undergoing mutation, and now due to this mutation, it is changing day by day. So it is very difficult to identify it or to find the accurate treatment for this due to this mutation. So these X-rays can cause the mutation in our DNA and therefore might lead to the cancer in the later stages of the life. If a technician or certain human being who actually underwent multiple x-rays, right, or the technician which exposed themselves during his or her service period towards this x-rays, right, it is possible that they may develop cancer in the later stage of the life, right, because they are carcinogenic in nature. Because of this reason, x-rays are classified as the carcinogen both by the WHO and the United States of the government. However, the benefits of the x-ray technology far outweigh the potential negative consequences of using them. That's why we are using them. Okay. And then the certain kind of the diagnostic kit, it is something very, very important. See, radio pharmaceuticals are radioisotopes bound to the biological molecule and biological molecule able to target specific organs, tissues, or the cells within the human body. Say if any tissue, any organ, or any part of the human body is suffering for the certain kind of the problem, and we need to identify what is the problem, then for this generally we use the radioisotopes. And for more specific things, you can read some pharmacy books, right? But for environment science, it is enough to know that we use these radioisotopes to identify any kind of the disease, right, or infections rather. These radioactive drugs can be used for the diagnosis, yes, as I have already told you, and increasingly now in the modern era for the therapy of the diseases. Now these actually radioactive drugs nowadays are also used for the treatment of the diseases as well. Please remember, this is something very, very important. So now I am going to discuss the diagnostic kits which are generally used for the diagnosis as well as for the now these days as well as for the treatment of the diseases. But before introducing exact diagnostic kit, let me tell you something about your thyroid gland. And so first of all, you should know your thyroid gland. Okay. This thyroid gland basically do the things for the entire body of the human being. And if some persons see if the function of this thyroid gland actually if this thyroid gland malfunctions, then there occurs the two kinds of the problems, and most commonly is the hypothyroidism. Okay. So, and what is hypothyroidism and what is hyperthyroidism, you should know these things. For example, say if you go for the thyroid test, right, thyroid gland test, so generally they measure TSH. And what is this TSH? TSH is the thyroid stimulating hormone. Please remember, I'm not writing, but you should remember. You can Google it or you can go through the books as well. It is thyroid stimulating hormone, and it is a pituitary gland hormone. And that hormone, actually this TSH, stimulate your thyroid gland to produce the T3 and the T4 hormone, right? So T4 and the T3 hormone, this is the function of the thyroid gland. And this TSH is basically the pituitary hormone which actually activate this thyroid gland to give T4 and the T3. So I have written in that way T4 and T3 because first of all, you see your thyroxine, which is your T4. T4 is your thyroxine, right? First it is produced, this thyroxine is produced, and after that T3 is produced, which stimulates the metabolism of almost every tissue of the body. That's why this thyroid gland is very, very important, right? First of all, you should know. And if you undergo for the thyroid gland test, and if your TSH level is in this range 0.4 to 4.0 milli-unit per liter, then that means you are normal person, you are not suffering any from any thyroid disease, right? But sometimes this range may go up to from 4 to 10 milli-unit per liter, right? And when this happens, that means your thyroid gland is actually not functioning very well, but this is the condition of very mild hypothyroidism. Okay. and when this value of your TSH hormone is greater than 10 milliunit per liter, right, that means you are suffering from the very severe hypothyroidism. Okay, and this hypothyroidism is very common. Generally there are two kinds of the problem, hyper and the hypo, but this hypo is very common. So please remember, higher value of the TSH means you are suffering from the, if the value comes above 10, right, then definitely you are suffering from the thyroidism. But if your range is from 0.4 to 10, according to me it's perfectly normal. There is no problem in that, and you don't need any medication to treat it. But if it is going beyond 10 milliunit per liter, then definitely you are suffering from the hypothyroidism. That means your thyroid gland is not producing T4 and T3 in the adequate quantity. That's why this TSH is actually excreting, or say it is coming out in the very large amount to hyperactivate this thyroid gland, so it can give more T4 and the T3, right? That's why the high TSH level shows the hypothyroidism. Please remember this thing. Okay, and then opposite of this is the hyperthyroidism, but hyperthyroidism is not very common. So what is hyperthyroidism, which is also known as the Graves' disease? This is after the name of the Irish physicist or physician, not physicist, I'm sorry, Irish physician, Dr. Grave, and after the name of the Grave, this hyperthyroidism is also known as the Graves' disease, right? And what are the symptoms of the hyperthyroidism? So you can see, heart palpitation is the first symptom of the hyperthyroidism. That means your heartbeat would be regular, sometimes very fast, sometimes slow. It is not regular. This is the symptom of the hyperthyroidism. And when you have the hyperthyroidism, your heart is beating fast, then definitely you would be intolerant towards the heat. That means you cannot bear a hot condition or the hot environment, right? You will not wear any heavy clothes and such things. That when you are suffering from the hyperthyroidism, you would be intolerant to the heat. And when these two happens, definitely the third feature is the insomnia. Insomnia means sleeplessness, right? You will not sleep in the entire night, right? And your sleep would be disturbed in that case. This is another very important symptoms. See, if a person is suffering from these three, heart palpitation, heat intolerance, and insomnia, right, then definitely that person is suffering from the hyperthyroidism, right? And when these three happens, then definitely the person would be nervous at times, be it in, say, in interview, or say in the public debate, or say in any function, right, or say in any say serious condition, that person would be very nervous. This is the symptom of your hyperthyroidism. And especially in the ladies, when the ladies are suffering from the hyperthyroidism, then this is another feature, decreased menstrual flow, right? During the MC, there would be less menstrual flow, and when this menstrual flow would be very low, definitely hormones would get disturbed, and when the hormone disturbs, then entire body will be different, and the person will suffer then with the serious diseases, right? So these are some of the symptoms. And what are the treatment of this hyperthyroidism? So generally, when the people suffer from the hyperthyroidism, since it is very rare, not very, that means not rare, but not very common, but generally the people suffers with this. When the people suffer from this hyperthyroidism, the treatment, what is the treatment? Treatment is what? Radioactive iodine oral doses would be given to that particular person. Iodine 131, it is radioactive in nature. Okay, so you can see this is the thyroid gland. You can see the thyroid gland, and this is the complete picture. Larynx is also there, but this is the biology part, you can skip it, and thyroid gland is there. Okay, and it may develop cancer. Okay, so what is the treatment? Iodine 131, as you can see here, radioactive iodine 131. In my first slide, I told you, whenever you see this kind of the symbol in any container, that means that container contains the radioactive substances. So this radioactive iodine 131, which is used in the treatment of the hyperthyroidism, is radioactive in nature. And what it will do, it will actually correct the malfunctioning of the thyroid gland, and that thyroid gland will now produce proper amount of the T4 and the T3. Okay, and that TSH level would go down then. Right, this is the treatment, and this treatment generally the person can take up to 3 to 4 months to work. Right, so after 3 or 4 months, definitely it will work. But please remember, in the less educated country, or say in the country where we don't have the much facilities, or so the people which are living in the say rural area cannot see the doctor frequently, people actually must be very careful. I do not want to discuss that thing here, because that person is no more now, right? That's why I'm not discussing that. But this happened to that person actually. She continued to take the cardiovascular drugs for a long time without visiting the doctor. And what happens? Her kidney got failed and she died. Okay, so it happens when you take up to 3 to 4 months, then you have to visit doctor for the latest report, right? Otherwise, what will happen if you continue to use this medicine? Hyperthyroidism will definitely go, but hypothyroidism will develop now. Okay, there would be another problem which is more severe than the hyperthyroidism. So you have seen what is hyperthyroidism. Then you have also seen what is the treatment, but the risk with the possible treatment you should know actually. What are the possible risks when you when a person undergoes such kind of the treatment, right? So be sure, first of all, the person which is taking this iodine 131, if it is a lady, she must not be pregnant. During pregnancy, we cannot use these drugs. Okay, so it can cause damage to the fetus, and newborn baby will have some defect definitely, right? So these medicine cannot be taken by the pregnant ladies. And another problem is the hypothyroidism, because you are treating the hyperthyroidism, and sometimes it may happen that the side effect may occur and your thyroid gland actually suppressed to that extent which give you the hypothyroidism. When hypothyroidism is there, then you will develop the symptoms which are just opposite to the hyperthyroidism. Just you have seen in the hyperthyroidism, generally people, the person or the sufferer actually is heat intolerance. But when hypothyroidism is there, then the person would feel cold all the time. It would be cold intolerance. That means need heavy clothes all the time, heaters, right? Sunlight, all these things that person will need now. Okay. Another very important side effect is that for a person suffering from the hypothyroidism, muscle cramps in the hand, cramps in the neck, cramps in the back. This would be very common. Okay, dry skin is a very distinct feature for a person who is suffering hypothyroidism. And definitely when cold intolerance is there, then definitely the liver would become sluggish, and that person may suffer from the constipation. If that hypothyroidism is not treated, then this prolonged constipation can give a person piles as well. Right, this constipation can give the piles to the person. If it is not okay, when liver is not functioning, definitely the energy would be poor for that person, right? And always that person will feel fatigue, low in energy. So these are the possible risk of this particular treatment, iodine 131. This is this one now. I think this is last slide, or say 1 or 2 slides left. Diagnostic kits, another very important diagnostic kit used for the treatment of the eyes, right? So this strontium 90 is also known as the bone seeker. Please remember, because it can accumulate in the bones in place of the calcium, and then it may cause to the cancer. It may cause cancer. Okay, so strontium 90 is used as a radioactive tracer in the medical studies and in the study of the medical crops as well. But for now, it is not important to know that what are the medical crops and where we use this strontium 90. It is enough to know that in the medical studies as well as in the study of the medical crops, we use the strontium 90. And also used in the electron tubes to treat the eye diseases. When the person is suffering from the eye diseases, then again in the electron tubes, this strontium 90 is used. Food and drinking water are the largest source of the exposure to the strontium 90 because it is there in the earth pool. When it is there in the earth pool, definitely it can come through the food chain in your water, not through the food chain. It can come through the water as yes, of course, through the food chain as well, right? In the drinking water as well as in the food material. Okay. And this strontium 90, which I have shown you here in this particular picture, right? Strontium 90. The strontium 90 is also known as the bone seeker as it accumulates in the bones instead of the calcium and causes leukemia. Which is the leukemia is a kind of the blood cancer. Okay. And it hinders the body's ability to fight infections or the cancer of the bone marrow, low immunity. All these are the features of the effect of the strontium 90. So these are the two very important iodine 131 and strontium 90 are used in the diagnostic kit. Very important radioactive tracer. Conclusion: what it can do? It can cause these radiation can cause genetic damage, right? Which induces the mutation in the DNA, as I have already explained. The damage often seen in the offspring, that definitely in the newborn babies, the damage would be more pronounced and may be transmitted up to the several generations. That means it can become the genetic disorder as well. Okay. And then there occurs the somatic damage as well, which include the burns, marks, right? Miscarriages, eye cataract, bone, thyroid, breast, lungs, skin cancer. For all these actually, for all these diseases, these radioactive materials are responsible. Okay. So how to control? So there are various methods to control the nuclear hazards, but on papers everything happens, but in reality, in the ground reality, you will find nothing. Okay. So first very important measure which every government must take, siting of the nuclear power plants should be carefully done after studying long-term and the short-term effects of the radiations, and proper disposal of the nuclear waste must be there, right? So these are the two important measures which must be taken by the any government prior to establish or say prior to establish any nuclear power plants in any area. Okay, so this is just the brief idea about the nuclear hazards, right? And very, very important topic of the general awareness as well, right? I hope you like the lecture. If you are following my channel, please like this video, and if you are new here watching video for the first time, please subscribe the Tetrahedron Chemistry classes and do share with your friends as well. I'll meet you in my next lecture. Okay, so that's it for today. Thank you very much.